Hey everybody, back with another Polars tutorial. Hope you're all doing real well. Today I'm going to be continuing my discussion of the Polars DS data science package in the Polars library, which allows you to do a lot of statistical tests that aren't included as part of the main Polars data science library. And today I'm going to be talking about how to do a bivariate correlation between two variables. And the data I'm going to be using today is college graduate data taken from a survey called the National Survey of College Graduates. It's publicly available. And I'm going to be doing a bivariate correlation between salary, so the reported salary of a survey respondent, and the number of reported hours worked in a typical week by a given survey respondent. So in other words, this person worked 40 hours a week. This person reported working 45 hours a week and earning $60,000 a year. And this person reported working 60 hours a week. So my goodness, 60 hours, it's a very long time. And so with a bivariate correlation, just to quickly review it, just measures the amount of concomitant variation between two variables. So there can be a positive and a negative correlation. So a positive correlation means when one variable goes up in value, the other variable goes up in value. And likewise, when a variable goes down in value, the other variable goes down in value. Now, a negative correlation means something a little bit different. It means when one variable goes up in value, the other variable goes down in value. Likewise, if this variable were to go down in value, salary would go up in value. So those are the two types of correlation that are typically that are measured in a bivariate correlation test. And so to get to the code, it's actually quite simple. So to do a bivariate correlation, and I'm skipping over just like the formatting I do and reading the data and all that, because that's really not what's important to us. What's important is just kind of the practical implementation of this test we want to do. And so the way you do this is you just do you point to the input data set, and this is the input data set is called NSCG, and NSCG, I just named it that because it's an acronym for the survey upon which this data is based, the National Survey of College Graduates. And we do .select because anything and everything in Polars is always returned as a data frame. So I don't think there's a lot that gets generated as like a written report, except things like .glimpse and whatnot, and there could be some other things as well. So, and then within .select, you do PDS, which is just Polars data science. That's the alias I gave the package up here. And then .core, and there's two methods, or three methods, or three arguments, excuse me. So there's an x argument, and that's just the first variable, and then there's a y argument, and that's the second variable, and then there's a method, and the method just refers to the type of correlational coefficient that you want to generate. And this is going to return a coefficient. And so since it's returning a coefficient, that's going to be a variable in a column, and so we need to name that column. And so that's why you'd say alias coef. That's just short for coefficient. And so the default correlational coefficient in the .core method is Pearson, and so we'll go ahead and generate a Pearson coefficient and just kind of see how that looks and see what those results look like. Okay, so there's our results for the bivariate correlation. So that means there's a 0.30 or 0.31 relationship between hours worked and salary, and so that's actually pretty strong for individual level data. So that means there's very strong evidence that people who work longer hours also tend to have higher salaries, which does make sense, especially if you're an hourly employee, like myself, if I might add. And so the default is Pearson, so we can also do a Spearman correlation coefficient. And I think there's a few others too, although I haven't explored them all. And I hate to admit this, but it has been a long time since I've taken stats, and so I can't quite recall off the top of my head what the difference between a Spearman and a Pearson correlational coefficient is. Perhaps somebody in the comments can fill us all in and educate us. But yeah, guys, that's how you do a bivariate correlation in Polars with the Polars data science extension. It's pretty easy and not a whole lot to it, but if there's any questions, definitely let me know in the comments. So thanks so much for watching and have a good day.